Okay, so in part three of complex numbers, you're going to learn how to simplify radical expressions. And basically, this is going to review from last semester. But just a reminder, by definition, the square root of a negative 1 is an imaginary unit I. All right, so we're going to need that part. Now, remember in a previous course, you talked about simplifying. Let's say you want to simplify the square root of a negative 4. All right, so we know that the square root of 4 is 2. The principal square root of 4 is 2. What about the square root of a negative 4? And the way we did this was we said, first of all, when we first talked about this, write this as the square root of a negative 1 times 4. And then you can rewrite this as the product of two radicals. Square root of a negative 1 times the square root of 4. And the square root of negative 1 by definition is the imaginary unit I. Square root of 4 is 2. So I times 2 is just 2I. So that's the idea you're going to use here. So let's look at this example. Let's say, in the directions we either say something like perform the indicated operations, or it could say simplify. It could be one of these. Okay? Alright, so number one. Let's suppose we had the square root of a negative 64 minus the square root of a negative 25. Alright, so first of all, the square root of a negative 64 is 8i, and if you don't see this, remember the square root of 64 is 8, but the square root of a negative 64 is the square root of a negative 1 times 8 times 64, which is square root of a negative 1 times the square root of 64, and the square root of a negative 1 is I, square root of 64 is 8, so this is just 8i. So mentally, you could have done this. So the square root of negative 64 mentally is 8i minus, subtract, square root of a negative 25 is 5i. I can combine these like terms, and so 8i subtract 5i is 3i. Okay, number 2. Suppose we had 5 times the square root of a negative 16 plus 4 times the square root of a negative 81. Alright, so this becomes 5 times, now the square root of a negative 16 is 4i, so this becomes 5 times 4i, which is 20i, plus 4 times the square root of a negative 81 is 9i, so 4 times 9 is 36, so 4 times 9i is 36i. Combining like terms, 20i plus 36i is 56i. Okay, number 3. Suppose you had negative 6 plus the square root of negative 48 divided by, let's say, 24. So negative 6 plus the square root of a negative 48 divided by 24. And directions will say also write in standard form. All right, so you're gonna perform indicate operations, and you're gonna write in standard form. So here, remember, standard form is a plus bi. So here a is 0, so just leave it as 3i. Here a is 0. Remember, 0 plus 3i, but just leave it as 3i. So remember, this is 0 plus 56i, but just leave it as 56i. So when we do this, we want to write in this form. So let's first of all figure out what the square root of a negative 48 is. So the square root of negative 48 is the square root of a negative 1 times the square root of 48. So the square root of a negative 1 is I. Now remember, you want to find a perfect square that goes into 48. So that's going to be 16. So the square root of 16 times 3. The square root of 16, remember, is 4. So that's I times 4 times square root of 3. So that's 4i square root of 3. So remember, when you have a radical, always put the I in front of the radical. Because if you put it in the back, it looks like this. It looks like sometimes the I may be misunderstood and it looks like it's under the square root and it's not. Okay, so don't make it look like it's under the square root. So that's why we tend to just put it in front. Okay, so this right here becomes negative 6 plus 4i square root of 3 divided by 24. And then remember, they want you to put in the form a plus bi, so just write it as two fractions. So that's negative 6 divided by 24 plus 4i square root of 3 divided by 24, and then simplify. So negative 6 divided by 24 is a negative 1/4, plus over here, they're both divisible by 2, so it's going to be, actually, they're both divisible by 4, so it's going to be, well, that's 1, that's 6, so it'll be I square root of 3 divided by 6. And so that's your answer there. So negative 1/4 plus I squared root of 3 divided by 6. All right, and then number 4, suppose you had negative 10 minus the square root of a negative 12 divided by 48. And so let's simplify this part right here. So that's going to be the square root of a negative 1 times the square root of 12. Square root of a negative 1 is I. Square root of 12, a perfect square that goes into 12, and you always want to choose the largest. So the largest perfect square goes into 12 is 4. So that'll be the square root of 4 times 3. The square root of 4 is 2. So that's 2i squared root of 3. And again, put the I in front of the radical and put it in front of the real part, the whole number part, and the irrational part, the square root part. So put it between the two. And so that becomes negative 10 minus 2i squared root of 3 divided by 48. And then we want to put it in standard form, so write as two fractions. So negative 10 divided by 48 minus 2i squared root of 3 divided by 48. And then reduce. So these are both divisible by 2. So it'll be negative 5 divided by 24. Minus, and these are both divisible by 2. So it'll be I squared root of 3 divided by 24. And so there's your answer. All right, now let's look at this example. So this will be an easy one. So if you have the square root of a negative 2 times the square root of a negative 2. Now don't make the mistake. This is wrong. This is a common mistake. It's just say, well, that's going to be the square root of negative 2 times negative 2, which is square root of 4, which is 2. So that's incorrect. All right, so the only time this applies, so you can say the square root of a to the square root of b is equal to square root of ab if a and b are both positive or 0. Okay, only if they're both positive or 0. So if you had the square root of 2 times the square root of 5, then that would be the square root of 10. That's true. All right, now, but if they're both negative, it doesn't work, because if you look at this, that is really I square root of 2, and that's really I square root of 2. I times I is I squared. The square root of 2 and the square root of 2 is just 2. And remember, I squared is negative 1, so that's 2 times negative 1, which is just negative 2, not 2. All right, so the answer is negative 2 and not 2. So keep that in mind as we go through this. The only time you can multiply the radicands is if a and b are both positive, not both negative, or 0. Now what if you had negative 2, square root of negative 2 to the square root of 5? Okay, so that could be the square root of negative 10, which is I squared root of 10. So that's fine. So if a and b are both positive or 0, or if either a or b is negative, but not both. Okay? All right, let's look at number 6. You have the square root of a negative 8 times the square root of a negative 3 minus the square root of 5. All right, now if I distribute this, you got to be careful, because you're going to get the square root of a negative 8 times the square root of a negative 3 minus, and then this times this, square root of a negative 8 times the square root of 5. Now, you can't say that's the square root of 24, positive 24, because we just saw that doesn't work. Okay, square root of negative 2 times square root of negative 2 does not equal the square root of 4, which is 2. It's supposed to equal negative 2. So you need to rewrite this as I first. So this becomes, since both the radicands are negative, you need to rewrite it first as I. So it's I squared root of 8 times I squared root of 3. And then just dealing with this part right now, this becomes I squared square root of 24. And then square root of 24 is, let's see, 4 times 6. And the square root of 4 is 2. And this is negative 1. So that's negative 2 square root of 6. That's what this piece is right here. So remember, I squared is negative 1. Square root of 4 is 2. So negative 1 times 2 is negative 2. And you'll look for the square root of 6. Over here, best thing to do is, now since only one's negative and the other one's positive, you can go ahead and multiply them. So it'll be the square root of a negative 40. So that you can do. You can't do this approach. You can't multiply the radicands if they're both negative, so you need to rewrite them as i's first. Okay, so they'll be minus, and then there'll be I square root of 40. And then 4 goes into 40, so that's I squared of 4 times 10. And the square root of 4 is 2, so that's minus 2I squared root of 10. And you can't simplify this, so that's your answer. Okay, so that's going to take care of part 3. Number part 3, you had to use this throughout. Some of this was reviewed from last semester. Some of it right here, like these, some of it was kind of new. You can't just multiply the radicands if the radicands are both negative. Okay, so that takes care of part